Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for previous NEET questions from the chapter Moving Charges and Magnetism. First question. A long straight wire of radius A carries a steady current I. The current is uniformly distributed over its cross section. The ratio of the magnetic fields B and B dash at radial distances A by 2 and 2A respectively from the axis of the wire. So we need to find the ratio of B to B dash. So just you draw the diagram. The wire is just like a cylinder. Yeah. So this is going to be the cylinder. So its radius is mentioned as A. So say this is axis. So this is going to be A. But in the question it is mentioned that at a distance A by 2. So therefore half of A. So this is going to be roughly A by 2. This is the particular point, roughly it will be at A by 2. Field at A by 2. Also field at 2A. Already there is A. So there is, in addition to A, there is one more A. Altogether this will be 2A. So get back the Ampere circuit law. B is equal to mu naught I. So this is output of Ampere circuit law. Mu naught I by 2 pi R. Yeah. So field at a given point due to a straight conductor. Now, so I inside, let us find out I inside. So I by area is equal to main current by area of the cylinder. So straight away it can be pi A square. So therefore, I in terms of capital I. So what you can write is I by pi A square with the pi R, with the this area you write on pi R square. So therefore this will be pi R square. But what is R as per the question? It is A by 2. So the main current is going to be the current inside. I is equal to I by pi A square with the pi. R is A by 2. So it means A square by 4. So pi and pi get cancelled. A square get cancelled. So therefore I is equal to I by 4. Now let us substitute this here. And it is also mentioned that R is A by 2. So therefore mu naught I is, you can write I as capital I by 4 along with 1 by 2 pi R. 2 pi R is A by 2. So 2 and 2 get cancelled. So altogether this will be mu naught I by 4 pi A. You call this is the first equation. Then, so this is the field at a distance A by 2 from the axis. Now field at a distance 2A. 2A means what? From outside it is A. So therefore B is equal to mu naught, straight away mu naught I by, it is going to be 2 pi R. So what is R now? From the center at a distance 2A. So mu naught with capital I divided by 2 pi with 2A. So therefore this is going to be mu naught I by 4 pi A. Mu naught I by 4 pi A. So therefore even this is also going to be mu naught I by 4 pi A. Call this is second equation. Even you got first equation also same. So therefore if you divide them, if you divide B dash, this is called as, so B dash is the magnetic field at a distance 2A from the center of the wire. So B dash and B, okay, when you don't need to do this, B dash is mu naught I by 4 pi A. Even B is also mu naught I by 4 pi A. Mu naught I by 4 pi A. They both get cancelled. So the answer is 1. So same. Moving to the next question. A square loop ABCD carrying a current I placed near and coplanar with a long straight conductor XY carrying current I. So we need to find out the net force on the loop will be. Remember the conductor BC, and AD will be parallel to the field, due to I flowing through XY. Why? Because suppose just imagine that this is XY. In case if current is upwards, so upwards means the field will be formed. Assume like this. Field will be formed like this. We'll decide whether it's clockwise or anti-clockwise afterwards. Yeah. So you are drawing circles on the plane of paper. Suppose let us say this is the current. Yeah. So therefore, let's assume that here somewhere there is a loop, so square loop of side AB is there. Square loop of side AB is there. So this is, understand that AB of length L. So therefore, when current is upwards, while crossing this particular point, field will be, so tangent drawn on the circle will be the field. So therefore, field will be like this. So therefore, this particular magnetic field here, magnetic field and length will be perpendicular. So this is AB, side AB of the loop. So will be perpendicular. So whereas if suppose if you take a BC and AD, it will be like this. So therefore, either length AB, AD may be parallel, or BC may be parallel. So therefore, in the expression of force, we have an expression of force of L cross B. So if you remove cross product between two vectors, then sine theta. So therefore, theta will be 0 or 180 for the case of BC and AD. So therefore, force on BC and AD does not exist. So this is the reason. So only there will be force on the sides AB as well as CD. So now, so remember, there is a current here upwards. Even there is also current upwards. So I think in theory you might have studied that when two currents in two conductors are flowing in the same direction, they attract. So therefore, this side AB and the conductor XY attract. So move to the next case, CD. So somewhere just to extend even magnetic lines of force also. Yeah. Okay, suppose let us say one more circle you take. Somewhere here, CD is there. Somewhere here, CD is there. How the current will be? So here, current is downwards. So therefore, with respect to XY, it is opposite direction. So therefore, due to this XY, the side CD get repelled. So field may be in the same direction. So therefore, this CD get repelled, whereas AB get attracted. So there is attractive force, there is repulsive force. First you write down force on conductor AB. So this conductor AB is at a distance of L by 2 from a corresponding. So get back the formula. Mu naught I1, I2, L by 2 pi. This is the basic formula, R. So what is R in case of AB? AB is L by 2. So R is L by 2 here. Similarly, force on CD. So this is repulsion. So it is at a distance of, this is force on CD. Formula is same, mu naught I1, I2. I is also same, L with the 2 pi. This is going to be L by 2 plus L. So CD is at a distance of L by 2 plus L. So it is L by 2 plus L. So therefore, this is going to be mu naught I1, I2 L by 2 pi with 3L by 2. Right. So therefore, since it is away, repulsive force is less than the attractive force, because R is less, force will be more. So therefore, attractive force on AB compared to repulsive force on CD less. So therefore, FAB minus FCD is equal to mu naught I1 I2 L by 2 pi. First case is L by 2 minus mu naught I1 I2 L by, second case is 2 pi 3L by 2. Right. So even you can straight away you can take out common. So mu naught, they mentioned in the question I is same. So therefore straight away you can write I square with L also. 2 pi you can take out common. Okay. You can do one thing. You proceed based on the options given. Yeah. So you can take out common 2 pi. So here this is going to be 1 minus. So there is L by 2. 2 will go up. 2 pi L also you can take out common. So this 2 will go up. Yeah, 2 by 1. Then next time, 2 pi L common. So this 2 will again go up after you take out common. So there will be 3 here. So therefore LCM will be 3. LCM is 3 means this is 3, 6 minus 2. So therefore mu naught I square L by 2 pi L. So there is 4 here. There is 4 here. Mu naught I square L by mu naught I square. Yeah. Mu naught I square small l by 2 pi L. There is 4 here. There is 3 here. So 2 times. So remember, they mentioned here capital I, they mentioned here small I. So therefore, so let us don't write I square. Just separately you write down. This is I and small I. This is L. Yeah. So L is side only. Then it is pi L with the 2 by 3. So this is 2 by 3. So L and L get cancelled. So answer is third option. Next. Moving to the third question. A long wire carrying a steady current is bent into a circular loop of 1 turn. So here N is 1 only. The magnetic field at the center of the loop, is B. So this is an application of Biot-Savart law. Then the same loop, it is then bent into a circular loop of N turns. Like this. As number of turns are increased, appropriately radius decreases same number of turns, same number of times. So the magnetic field at the center of this coil of N turns. So therefore, this is an application of Biot-Savart law, mu naught Ni by, in case number of turns are mentioned. But in the first case, it is N is equal to 1 only, radius is R only. So therefore, you call this R1 equal to R. In the next case, N is number of turns, radius becomes R2, you call it as, radius decreases by N times. So first case, B is equal to straight away, N is equal to 1. This is going to be 2R. N is equal to 1 mu naught I by 2R. This is the first case. Second case, mu naught Ni by 2. R is what? R by N. So therefore, this is going to be, this is, you call it as B dash. Mu naught N square I by 2R. So therefore, so this is first part only mu naught I by 2R, B only. So what you can finally write, B dash is equal to N square B. Suppose if they mention two turns, initially there is only one turn. If number of turns are 2 or number of turns are 3, if it is 3, it will be 9B. So sometimes they mention the value of B also in the first case. So accordingly, you have to adjust the answer. So second option is correct. So moving to the question number 4. So this is given in 17 NEET. An arrangement of 3 parallel straight wires placed perpendicular to plane of paper carrying same current I along the same direction as shown in the figure. Magnitude of the force per unit length on the middle wire B. So formula is same only. F is equal to, when two conductors are separated carrying their own currents, mu naught I1 I2 divided by 2 pi R. So let us apply in what way this particular equation can be applied in this particular question. So understand the question like this. Suppose let us say how to assume these conductors, how to imagine these conductors in the reality. Right. This is conductor B. Yeah. So where you assume conductor B is, here you assume conductor B. This is conductor B. Okay. Then arrangement parallel straight wires. So therefore, here is one conductor. Here is another conductor. Yeah, distance is same. So therefore, this is D as per the question. So here is conductor A, here is conductor B, and here is conductor C. So this is also D even. Okay. So this is going to be conductor C, carrying current in the same direction. So when current flows in the same direction, B may be attracted towards A, even B may also be attracted towards C. So forces are perpendicular. So first let us find out one force. So finding one force is enough. So then thereafter applying parallelogram law, we find out the net force. So first F is equal to mu naught, carrying same current, you can straight away you can write I square L divided by 2 pi D, because R is D now. These two conductors A, B, and okay. This is between AB, force, attractive force between AB. Similarly, attractive force between BC. Same equation, mu naught I square L divided by 2 pi D again. Now these two forces are perpendicular. So therefore make use of parallelogram. You call this is F only. Even this is also F. So F and F are perpendicular. Making use of parallelogram, F resultant is equal to F square plus F square. So therefore 2F square cos theta. Theta is 90 here. Therefore, that particular term does not exist. So therefore, you will get this is a root 2 without root F. Substitute this here. So therefore, F resultant is equal to root 2. F is this mu naught I square L by 2 pi D. Yeah. So let us check which option is correct. This is root 2. You can make this 2 as root 2 into root 2. So therefore, mu naught I square L by root 2. After you making this is root 2 into root 2 pi D. So third option is correct. Moving to the next question. A metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane, which makes an angle 30 with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field of induction 0.25 Tesla is acting on it in a vertical direction. So we need to find out the current. So this is given in 2018. So I assume like this. So this is the inclined surface on which you are placing a metallic rod, which might be carrying some current. Then magnetic field are applied like this, the vertical direction. But so this is the plane inclined surface on which there is a metal rod. Assume like this. So this is the metal rod. This is the metal rod. Maybe carrying some current. Yeah. Then, so magnetic field is applied. Resolve magnetic field into two components, keeping the inclined plane as x-axis, or let us say axis, reference axis. So therefore, inclined surface is the reference axis. This is inclined surface. This is magnetic field. Yeah. Next. So weight of the rod acts vertically down. Here, the component of weight is responsible for the rod to move down. So that is mg sin theta, resolving weight into two components. So normal reaction anyhow will be like this. So therefore, this is mg cos theta. This mg cos theta does not play anything here. Yeah. So this is B. Ensure that B is vector. Then let us resolve B into two components. So if you want to have resolution, treat B as hypotenuse. Suppose if this is theta, this is theta. So this will be opposite. Then this will be adjacent. So adjacent will be along. Then, so vector B will have components like this. So this is going to be B sin theta. Now B cos theta is trying to stop the conductor not to move down. So therefore, but there is a magnetic force. So what is the expression of magnetic force? F is equal to I of L cross B. Yeah. So now B is what? ILB. It is ILB only. ILB. Yeah. So therefore, B is now B cos theta. So it is going to be ILB cos theta. This ILB cos theta is opposing the component of gravity not to move down. So therefore, they get balanced. It is mg sin theta is equal to ILB cos theta. Now, m by L they mentioned in the question. So m by L with g sin theta is equal to IB cos theta. So cos 30. What is cos 30? Cos 30 is root 3 by 2. Otherwise, there is sin theta, there is cos theta. Straight away, you can write this is going to be cos theta. Even you can also write B, right? So m by L they mentioned in the question, it is 0.5. 0.5. G is a 10. Yeah. Gravity, acceleration due to gravity. Sin by cos is tan theta. Divided by B. B is mentioned in the question 0.25. Is equal to I. So this you are looking for. So tan 30. First, this is 5. 5 by this is 0.25 means 1 by 4. So tan 30 is 1 by root 3. So this is going to be 20 by is equal to I. This is going to be 20 by root 3. 20 by root 3 means this is I. So this is 1.7. 20 by 1.7. Ensure that 200 by 70. Yeah, 17 tens are roughly 170. Okay, 17 tens are 170, 17 11s are, which is close to 190, 180, 190. So therefore, fourth option is correct. Students, in my next video, I'll continue the explanation of the remaining questions. Don't forget to share and subscribe with your friends and relatives. Thank you very much.